Little resource here, just thinking about quadratic equations. So I'm gonna actually title it that, and I can share this with you also. So quadratic equations involve an unknown squared, right? So this would be like a linear equation, right? This is a quadratic equation. So with a linear equation, there are some techniques you've learned to find the value of x that makes the equation true, mostly involving inverse operations, right? To add or subtract, multiply or divide to the same side, the same value to both sides. But what about if there is a value squared? Well, this doesn't change a whole lot of things if there's no linear term. And what I mean by linear term is a term that's multiplied by x. So in this case, doesn't change much. We're just going to add 2 to both sides, try to isolate on one side of the equation the quadratic term. And then graspable math, kind of cool. If you drag the squared to the other side, it will square root both sides. You could also do that by clicking and hold the equal sign and square root both sides. So, and what's great about graspable is it reminds you that there's 2 solutions. There's the square root of 10 and there's the negative square root of 10. Both of these make this equation true. And I'd always love for you to see very clearly that those are the values that make the equation true, right? So graspable, you can plug them in super quickly. No reason to not check your work. So this right here is 10. Boom. This is also going to be 10, right? Because we're squaring negative, right? So we end up getting 10 also. And so 8 equals 8. Now, I'm going to use, I think approximations are, okay to use, especially if that helps you make more meaning of the number. So of the value, the solution of x that makes the equation true. So this would be the approximation for the value of x that makes this equation true. Notice how I'm always kind of really into saying the value of x that makes the equation true, because I just think that that's what solving an equation is. And the more you get that in your head, the more you'll always have kind of a north star almost to go towards, right? We're trying to find the value of x that makes this left side equal to 8. Okay, so let's look at a different type of, so what happens when there is that linear term, all right? So now there's this linear term. Well, we could go one of 2 ways. We could use the zero product property, which works if one side's equal to 0. Well, I can do that pretty easily here. I can just simply subtract 8 from both sides of the equation. And now I do have 0. So zero product property is great if the left side of the equation can be factored. So let me ask myself, can this be factored? What does it mean to factor a trinomial? Well, can it be multiplied? Do 2 factors multiply to make this trinomial? Well, 8, I know that the numbers need to multiply to get this c term, the third term, and their sum should get this middle term. So it sure looks like maybe 4 and 2 might work. So negative 4 and positive 2 could definitely work here. And that was cool. I did that quickly, but Graspable Math has a little template. It doesn't do the factoring for you, but it'll help you with the template. So negative 4 times 2, I'm just checking. If I were to multiply that, I'd get this. Negative 4 times x is negative 4x. X times 2 is 2x, so I would get that. So this does factor, so that's great. So that means I can use I'm going to change that to a minus. I just like the way that looks a little better. That means I can use the zero product property. So the zero product property says that if factor A or factor B has a value of 0, this whole left side has a value of 0. And that makes sense because they're being multiplied. So in other words, my result, I have 2 equations that result here. I have x minus 4 equals 0, and I have x plus 2 equals 0. Well, those are pretty easy to solve, right? We know in one case, we don't even really need to solve these. We know that x equals 4 in one case and x equals negative 2 in the other case. So plus 4, but we'll just do it for fun. Again, I just love using Graspable Math. I know I talk about it a lot because I feel like it's almost like having your own, it's like, to me, it's like spell check, right? It's like you've got software constantly making sure that you're using the right grammar, right? The right algebra. So let's check to make sure that these equations are true. Always substitute into the original equations. So I've got two versions of there. I love how Graspable Math does this. I can just substitute right in. Okay, 16 minus 8, perfect. 4 minus -4 is also 8. Now, what's cool is I'm going to actually take this equation again. I'm going to drag it down. And I'm going to show you that, let's say you didn't see that this was factorable, and you didn't, rearrange this to have 0 on one side. Could you still solve this quadratic equation that has a linear term? You sure could, and you could solve it by using this idea of completing the square that we just talked about recently. So completing the square involves in adding something to both sides of the equation, so the left side is a perfect square trinomial. In that case, it's -1, and this will reveal itself shortly. So if I now factor this, I know that -1, whoops, I just hit a roadblock here, hold up. I wanted to add +1. So I'm gonna add +1, and that will allow me to get a -1 here, a -1 here. See, it's easy to miss these signs sometimes, right? So -1 times -1 gives me +1. -1 plus -1 gives me -2. So this is a perfect square trinomial because it can be written as 1 factor, let me see if it'll let me do that, squared. So why is this helpful? Here's what I would love for you to take away from this. You have just created, instead of having 3 terms, one of which is squared, one of which is linear, one of which is just a constant, you have created 1 term squared. So you've actually done this. I know it's hard to see that sometimes, especially when we're first doing algebra, but this is just something squared. Guess what? This is just something squared also. So we can square root both sides. So again, think about that. This is just something squared. It just looks more complex because there's a parentheses and there's a -1, but that's really all it is. So now I'm going to add 1 to both sides. And so I have, here's my resulting equation. It is, well, that actually is a perfect square. So plus or minus 3 plus 1. Well, let's see what both of those look like. So it's either going to be 3 plus 1, or it's going to be, the value of x is going to be -3 plus 1. Okay, well, doesn't that match what we did when we used the zero product property? 4 and -2, doesn't that match? So it's kind of cool. It's like, we have a lot of strategies, right, that we can use. There's actually, you could use the quadratic formula too, which you're going to learn about shortly. But, if we would have made this right side 0 and then realized that this couldn't be factored, we probably would have had to backtrack and complete the square anyway. So it's kind of cool. Complete the square will kind of always work for you, but it might not always be the most efficient, right? We added 1 to both sides to complete the square. But sometimes we can rewrite this as 2 factors, a times b equals 0. We're going to get the same value. And I'm not going to check these two because I already know that those two work. So I hope that was a nice little kind of crash course in understanding how to find the value of x that makes a quadratic equation true.